Hi, my name's Ed Snodgrass. I want to thank Linda and Aramis and the crew from Greenroofs.com for putting on the World Green Roof Summit. I live in the East Coast of the United States and run a small green roof nursery for about the last 15 years. And we have shipped projects all over the US and Canada and some into Asia. And I do consulting in North Africa, Europe, New Zealand, Australia, China, and thereabouts. So I'm happy to be talking today about plant selection relative to the function of the plants and the geography of the roof location. So I look forward to you enjoying the presentation, and thanks so much. Bye. Well, this is Ed Snodgrass with the World Green Roof Summit Talk, and we're going to talk about plants today. And a lot of plants get put on green roofs, but we don't really think about what we want from these plants and what we don't want from these plants. So first of all, if green roofs is a harsh condition, so first thing we want is the plants to survive. And then we want them to perform some sort of function. Those are the two things that always are assumed when people specify plants. But then we also, if we think about it a little more, we want them to live a long time. It's a real problem to put things up on roofs. So you don't want to replace plants every year or two. It's not like gardening. And then many of these roofs are for ecological reasons, so we don't want them to, we require a lot of ongoing fertility and water and nutrient, because all that will flush right out into the receiving waterways or the stormwater system. And then what we don't want them to do is we don't want them to be weedy, we don't want them to spread off the roof into the general landscape, we don't want them to be untidy, and we don't want them to be prickly or poisonous if people come in contact with them. So we have things we want plants to be and things we want them not to be. We really have to think about plants. One of the things I see all the time is plants get specified on a very large geographic level. So someone will say, oh, okay, these are green roof plants and they're in Baltimore, and then the same plants will end up on a specification in Los Angeles or Minneapolis, and that really isn't correct. So the USDA has put out a heat zone map and a hardiness map. Now the hardiness map is based on the average low temperature for that part of the US expressed as a zone. So the lower the zone, the colder, and then the heat zone map is based on how many days above 30 C exist in any particular location. 30 degrees centigrade is the point at which plants start to experience heat stress or heat fatigue. So those two things have been used a lot in horticulture. I'm not so sure how much they're used in green roof specification. In addition, I'm kind of a fan of the Cohen-Geiger climate map. And this helps. This is a worldwide map based on climate type. And this is really handy because while you can know hot or cold, you don't really know annual rainfall, relative humidity. Cohen-Geiger gets into available rainfall versus potential evaporation. So for example, in England, you may not get all that much rain, but it's very humid, so not a lot of the water doesn't leave the roof, whereas in a place like Melbourne or Johannesburg, South Africa, the humidity is very low, so any rain you get goes right back into the atmosphere. So all these things have to be considered when using plants. So here are some rainfall data from 3 different cities that have the same annual rainfall. So they are Jerusalem, Stuttgart, and London. And you can see that, oddly enough, Jerusalem and London have the same rainfall. You probably wouldn't think that. Jerusalem gets almost all its rain in about 1 month of the year in the fall, statistically. Stuttgart has a wet summer, fairly evenly distributed rainfall, but a wet summer, and England has a wet winter and spring and a little bit drier summer. Annually they have, so if you just said, oh, I got to put in plants for some place that gets 25 inches of rain a year, then you wouldn't have the whole story. So that's why you need this local data. And you have to realize also that data is a long-term statistical average. So you may say, well, excuse me, Jerusalem gets this 25 inches of rain, but they may have a year where they get 40 inches of rain. So you also have to look at the anomalous years. Here's a rainfall chart of Maryland, where we had a hurricane in the fall and we had this amazing amount of rain in 1 month. Outside the statistical average, you can see the yellow line being the statistical average. So you also have to design for these anomalous events and think about, well, what if it did get a big inundation? Could the plants survive that? We don't live in a world of perfect averages. Then we need to think about, apart from climate and geography, is what kind of plants are there? There are really three kinds of ecological plants. Dr. Grimes worked this out in the 80s. There are ruderals or annuals, and these plants come in after a disturbance. So they have a seed bank or seed blows in. So let's say there's a lava tongue or a flood or an earthquake or a forest fire, these kind of massive events that the earth went through. Plants that come in and pioneer that new soil are called ruderals or pioneer species. And they have their place on green roofs maybe as introductory plants for the first couple years. And then you have competitive plants. So these are plants that are long-term winners. If you look at places like the Mongolian steppes, the savanna in South Africa, these tend to be mostly grass species or highly competitive perennials, and they can get in and really take over some territory. And then you have the stress tolerators. So these are plants that can live in places where nothing else can live. Plants in deserts or on rocky slopes, or in plants that are in extreme weather of some kind or another. And the stress tolerators tend to be your green roof plants because green roofs are highly stressful. So you don't see a lot of competitors getting enough out of an extensive green roof to really get themselves established. There's just too much stress. And then there's a whole bunch of areas in between, something that's mostly stress tolerant with a little bit of competitive edge, or something that's an annual but very competitive because it puts out a lot of seed. So you can see in Grimes triangle, there's also combinations of letters. So this is a very helpful overlay, I think. Here's an example of a natural habitat that has stress tolerators. And this is the Alvar Plane in upstate New York. And this is an old seabed. It's stressful because the soil profile is very low. The sun bakes on that limestone. The pH is unusual, so the pH goes from 8.5 to 11, so it's very basic. So plants from here are trialed on green roofs at the New York University of Ecology and Forestry. So these are the kind of things where plant collectors would go and look at these for possible green roof applications. Here's Dr. Cohen from the University of Maryland Green Roof Research Center, and he and I went on a plant collecting trip in California, and we're looking at plants in the Huntington Botanic Garden, plants that come from different parts of the world. It's nice to go to one place and find all these collections rather than have to go to all those different places in the world. So we can look at those plants, and we cataloged and photographed and spent time with the curators. So it's another opportunity to look at plants that may be applicable for green roofs. Here's kind of the stress tolerant area that kind of spawned the green roofs in Europe. This is kind of the rock outcroppings in Central Europe, and this is where a lot of the European sedums evolved. And so you can see this looks kind of like a rooftop, and these plants are very have evolved in areas that look a lot like a commercial rooftop. Very thin soils, very opportunistic in terms of water use. Succulent leaves, succulent roots. Sometimes they can slough all their leaves and roots and live with just a little piece of itself, and then opportunistically, when water comes, grow that out of the infrastructure back. And they live where nothing else really wants to live too much. So here's a picture of a Sedum album, and this is a commonly specified plant. And I think this is a real misunderstanding in the marketplace, that people just go, oh, green roofs, that's just sedums. But it's much more complex than that. The Sedum genus has about 600, 700 species, thousands of cultivars, and even within Sedum album, I have looked at over 150 different forms of Sedum album and tried a lot of them, and they are highly variable, and their genetic range goes from near the Arctic Circle down to North Africa and out past the Balkans and into the Caucasus. So all those are very different climates, and so you have to look at where your roof is and what plants might be appropriate for that. On the other end of the spectrum, this is a photo of Sedum Tornado, which is an East Coast native, native to Maryland, and people want to put this on a green roof as a native plant in Maryland, because they say, well, just natives must be better. But if you look where Sedum Tornado wants to grow, it's a streamside forest understory plant. So it doesn't want to live in anything that resembles a roof at all, even though it's a sedum. So there it is, growing under these big tulip poplars and alongside a stream like that. That's its habitat. So if you have a roof with a stream running through it and giant trees, then maybe that's the sedum for your roof, but most of the time it's not an appropriate plant for a roof. Another interesting place to look for green roof plants is lava fields, and this is Lava Beds National Park in Northern California. So this lava tongue is about 1,100 years old, and very few things have started to grow there, so you can go there and see, well, what are the rooterals, the colonizers there, and maybe that can give you some idea of what plants would be good on a green roof. And I found a little buckwheat, so that's one plant that is a possibility there, the little Areum. Now plants evolve different strategies according to where they live. This is a plant from the southern part of the African continent, from South Africa or Namibia. And it's developed it's taken some of its cells and taken the chlorophyll out and just made them transparent. So without chlorophyll, it's just light hitting this little cell with just water in it, and it becomes highly reflective. So it can lower the surface temperature, and which can be very handy for green roofs in places that have high solar radiation and low humidity. So this is a plant that's highly evolved for that circumstance. Probably wouldn't be great for a hot, humid climate because it hasn't co-evolved with a lot of access to rainfall. Another strategy plants form is that they just live during the good times. So you have to look for plants. This is Sedum Lanceolata in Colorado, and it looks beautiful in the winter and into spring, and then once it flowers, it pretty much just goes away. So you might think, oh, this is just a wonderful plant, and it's a native from a dry mountainous area, but it has no visual interest at all from probably the end of May until October, November, when it reemerges. So you wouldn't want to have this just by itself. You want to have this sprinkled among other things. It doesn't really spread that fast. but it can tolerate a good bit of stress. When the heat stress comes, it just goes away and takes a vacation. You could also just go to urban areas and look for what's growing on roofs. So this is in Casablanca in Morocco in North Africa, and this is an Onium species. So this is just a wonderful naturally occurring green roof. You can look at this and say, well, boy, if I was working in North Africa, this would be a nice plant to have. And this is a north-facing roof, so I walked on the south side of the building, there wasn't a single plant. So obviously there's some condition. If it gets a little too hot, it goes away. It just needed that little bit of northern exposure. So, but it is a nice plant. And this is in the Hunan in China. This is a sedum, is an annual sedum called magniflorum, and this is existing without any soil on clay tile roofs, and very, very nicely in flower. But again, once it flowers and it's done, it's just going to be a clay tile roof again with a bunch of seeds on it. Here's another photo in China. This is in Taiyan in Shanxi province, and this is Orostakis fimbriata, naturally occurring there. And so this is another possibility on green roofs. Very cold hardy. I mean, I've seen this up in places where it gets minus 25 centigrade, but it's also a grayish plant, so it doesn't really stand out that much. But a good source for butterflies for nectar in the fall migrations. And there's one in flower. This is Orostakis aggregatum with a fritillary on it. And so, you know, you can start to think about these plants in terms of, well, what do we want them to do? Do we want them to be a nectar source? How does that coincide with the migration times of these animals? Does it flower at the right time? Does it provide a larval source too? Some place for the butterfly to lay an egg and have a larva. So all these kind of things go into thinking about plants. Here's Sesli gumiferium, which is a good larval source for any of the swallowtail butterflies. So the nice thing is that this really helps the butterfly populations in terms of something to eat. The bad news is aesthetically, the larva eats the plant. So it's not going to be a highly ornamental garden if the butterfly eats a good bit of that plant and it just leaves a bunch of stalks. There's been a lot of talk about urban beekeeping, but unless you have a source for the bees, a reliable source for their nectar and pollen, then you're just always going to be buying bees. So cities are not full of life for bees, so you might have to supply some of that on a green roof and make sure street trees are good in that area. So all these things we intend to do with green roofs come with a good bit of knowledge. Here's some test plots for some plants we got from the Badlands of South Dakota and in the upper Midwest of the U.S. And so these are plants that all exist in the East Coast, but these are selections from a much tougher climate. So we may end up really developing cultivars for green roofs that are selected especially for that stress and are not necessarily the same cultivars that are in the ornamental trade. The other thing that happens with green roofs is it can affect the size of plants. So here's an Eriogonum allienii, and it's up around half a meter there, about 18 inches. And then that's in the field. When you look at it on a green roof, they both were about 4 years old. It hasn't reached 10 centimeters yet. It's those two little plants on either side of the measuring stick. So green roofs can really affect the size of the plant, the height, the vigor, and you have to understand that before you specify plants. The other thing you want to look is how much, if you're doing a roof for stormwater, how fast can the plants uptake the water after a drought? Can they survive? What are their strategies? So here's a Delosperma nubigenum after a month of no water. This was done at Penn State University. And then a rainfall was simulated overnight, and here's the next morning. So, so you see how rapidly that plant can uptake moisture and take advantage of that rainfall. And you may live in a climate where those rainfalls are infrequent, and you have to have plants that take advantage of that rare opportunity for water. And some plants take 2 or 3 days of rain to wake up and start collecting water again. Plants are also used ornamentally. So this is at the University of Melbourne in Australia. And this is a multi-layered plant. This is a plant laboratory actually run by John Rayner and Dr. Claire Farrell and Nick Williams. So they are looking at different depths and different treatments, plants from different parts of the world. So they're doing a kind of multifaceted plant study for Mediterranean climates. And it's a great place if you're in the southern hemisphere to visit and take a look. But they also wanted it to be a place where people could come at the university and relax and sit outside. So it's combined plant research and ornamentation and human participation. So it's doing a lot of things at once. And here on the other side of the building, Nick Williams is looking at Australian natives and kind of replicating a dry gulch, dry grassland, and so it has a very different look. And it's not intended to be a highly ornamental space, but it provides a different set of services than a place where people come and relax and want an aesthetic service. So for those of you who are specifying, you have to be really clear that when you make choices, there are consequences to the choices. You can't have it all in any landscape. This is from the set of The Hobbit. My son and I visited last fall, or last spring in the southern hemisphere, last fall up here. And this is a whole nother kind of green roof where it's built for a movie set, so it has to be perfect every day. There may be someone misting little droplets of water on it for just the right shot, and all the things around it are going to have to be just perfect, but because it's for such a special event. And then in Auckland by the airport is a roof that's Australian native grasses. So this is in a totally different design intent. So rather than a movie set, this is meant to express part of New Zealand's heritage for these native grasses they have. A lot of Carex species come from New Zealand. And then again in New Zealand, this is in the South Island at Mount Difficulty Vineyards, and this is a green roof over the barrel storage facility, and this roof is designed to evaporate the water that's used to rinse the barrels. So they pump the water up there, and the roof pumps that water into the sky. So they're looking for plants that are highly evapotranspirative, that bring water back to the atmosphere that transferred from the soil to the sky. So just to kind of finish up, I've been doing a lot of traveling in China. Here's all the, well, maybe not all the cities I've been to, but most of them that I can remember. And in traveling in China and working there, I think there's a new condition for plants that I hadn't thought of before, and that might be atmospheric deposition. What happens to plants when they are just covered with a lot of heavy air pollution, when that dust falls out of the sky and it's full of pollutants that may be heavy metals or may be high in nutrients like nitrogen and sulfur, or they may have cadmium or lead or mercury from burning coal. So we don't really know what effect that has on plants. Even just covering the leaves so the sunlight can't get to them, or the lack of sunlight in the cities. Well, what are the plants that can live in those conditions? What are the plants that can really help with that? And we may not know that yet. That's interesting stuff to look at. So here's another right in the same area. This is Nanjing. Here's this Orostakis fimbriata seeming to do pretty well. I see that around China a good bit. So it may be a start of plants to look for there. And also in Nanjing, there's a lot of vegetable production up on the roof. So this is eggplants and microgreens. And what is the implication of the pollution on them? What is it? What are the protocols if you harvest that? Should you be rinsing that? Does it matter? So there's, we don't know what's falling out of the sky on those leaves compared to growing them in the countryside and trucking them in. And that's probably true of American cities as well. So there are a lot of things to think about with plants. I think the plant specifications that I've seen, it's gone from really thinking about it to being very casual with it. So I think it's time to kind of re-energize some of the scrutiny about plant specification. I think that would be a good thing. Here's just a quick shot of the giant Buddha in northern China with part of our China team, just to prove I was there. And just to finish up, I've helped write some books, a pamphlet for the Brooklyn Botanic Garden. I did a chapter in the New American Landscape for Timber Press, and some green roof books. I'm happy to work with Dr. Nigel Dunnett and Dusty Gedge and John Little on a small green roof book. And then my first book, the Green Roof Plants book, is now available in French and English and Mandarin. And then the book I did with Linda McIntyre, the Green Roof Manual, is just available in English. I think it is being translated into Mandarin sometime. But I really appreciate the opportunity and the time to speak, and I hope you enjoy the World Green Roof Summit. Shishini.